What were we doing? I guess adding a player paddle. So how do we do that? Well, we know about character body 2D now. We've used that a couple of times. Let's add a new one of those. And we are going to call this player. And let's see, what do we need to do? We're gonna move the player there-ish. And we're getting complaints. We don't have a collision shape 2D. We'll also want to add a sprite. So let's add the sprite. And we'll just use a placeholder texture. We're gonna want to I don't know, make a reasonably sized paddle for us. So things I think there's, even a game as simple as Pong, there's a lot of things we can do in terms of making it more challenging. So one thing we've already hinted at doing is making it so that every time the ball bounces, it gets faster. I think it's kind of a normal kind of additional challenge. But also make the paddle smaller over time, or they add like different modes, multiple balls. I don't know. Lots of things we could do. Collision shape 2D. And we'll add a rectangle shape. And we just need to make it the same as the sprite, right? We have smart snapping. Not working. Hard to tell. Oh, we're not. Let's yeah, there you go. Sometimes it's just easier to change the other thing. And at least in this case, where the sprite doesn't have an actual image, it's just a placeholder. That just works. Okay, so we have a player. It has a sprite and a collision shape. Motion mode of this should also be floating. And then we're going to add a script. Call it player, and it'll have basic movement. We'll use that template. That was my mistake. The first attempt. So the last Sunday stream, we started this without the template, and so we just tried to code something. I don't know how much of this will maintain, but we can start. So this gets us a character body 2D. We have a speed and a jump velocity. Jump velocity doesn't make any sense. Speed will be essentially how fast we can move the paddle up or down. We don't have gravity or a floor, so none of this is applicable. What we want to do is we already have defined for this project, because we're reusing the same project from last Sunday, custom inputs. So we have move left to move right, but that's not what we want. We actually want move up and move down. And so we want to change the Y velocity. So if we have an input, we set the Y direction velocity to be the direction of the input times the speed. And then, what does move towards again do? It moves param from, there's a number, towards param to another number by the delta amount, the speed amount. We will not go past param 2. So if we're not providing an input, it takes our existing velocity and ramps it down towards 0 by speed amount. So I think that behavior still makes sense in this context too. So we'll do that. And I think we can do right? So we don't actually need to use delta here. So I'll just put an underscore to make the warning go away. There we go. There we go. Now, is 300 going to be a good speed? I don't know. I don't know. We also need to find move up and move down. So how do we do that? We go to project settings. Is that right? Input map. Yeah, so here's where before we defined move left, move right, and jump. I'm going to leave those there for now, and we're just going to add a new one. We're going to have a move up and move down. Oh, and I can just enter there. That's good. So move up, we're going to add some assigned keys. So we're going to add W, and we're going to add up arrow. And for move down, we're going to add something that's going to be weird for others, but great for me. R is going to be move down, and down arrow. There we go. This is why thinking about this is why on the list of things for us to do is setting up UI, menus, and being able to customize this input map inside of the game, right? Because as someone who uses an unconventional keyboard layout, being able to remap keys is super important to me. So yeah. So I think at this point, if I just hit play, do we have a paddle? No. It does nothing. What about over here? No? Okay. Interesting. Interesting. So we're gonna access. Okay, so this is a shorthand for writing. Get action strength, positive action, get action strength. Negative action. Should this be the other way around? Negative action, positive action. So negative is in, the deduction goes negative. So, you know, the y coordinate increases downwards, right? So maybe this should be the other way around, although we should have still seen movement here. Maybe move and slide is not the right thing. Moves the body based on velocity, which is what we're updating, theoretically. If the body collides with another, it will slide along the other body by default only on the floor, but we've set the collision mode to be floating, so there is no floor. If the other body is a character body 2D or rigid body 2D, it will also be affected by the motion of the other body. You can use this to make moving or rotating platforms, so make nodes push other nodes. Modifies velocity if a slide has occurred. It won't. When the body touches a moving platform, general behavior and available properties change according to the motion mode, which is what we're talking about before with floating versus grounded. Okay, so can we print the direction? So it should be a bunch of zeros, and then when I input, oh, right. I have to go back to input mode. Okay, so I had it right the first time because this should be down and this should be up. So, okay. Cool. Yeah, so when we were trying to experiment with different things earlier, I had switched that toggle to 2D so I could actually click on the nodes in the game viewer, and I hadn't switched it back. So let's just undo until we get to where it's the other way around. Move up, move down. Okay. So if I click play, I can use my arrow keys, or W and R. And And I mean, this could be faster. This could be slower. I might want a little bit faster. Let's do a little bit faster. So back on the ball. Let's make the velocity randomized, or the direction randomized again. So now the ball will not necessarily start. It'll go in, you know, a random direction, and then it flies off the screen. Okay, so we have a player paddle. Let's actually let's do this again. Let's make this so that the velocity is negative. The direction is -1, 0. So we can make it fly towards the paddle. So we can see that the paddle does in fact have collision, and the ball will bounce. It does. All right, small victories. Small victories. All right, so what other things do we want to do? Add AI paddle. In fact, can I do like a checklist style thing here? Presumably, since this is Markdown. What else? So we'll have an AI paddle. It'll do things. We'll spend a little bit of time on that. I guess we then need to add, we'll call them goalposts, right? So that either side of the screen, the ball, when it enters the area, it will result in a score. And then some other stuff. Let's not get ahead of ourselves. There we go. Okay, so I think what I'll do is we'll do this a simple way. What if I just cloned a player? If I duplicate this, it does duplicate the whole trait. Cool. And I double click. We have AI. Can we grab? What is it? W for move mode. There we go. All right, we have an AI. No, we actually have to have it do something. So I want to right-click this. We want to detach that script, and we're going to make a new script. And maybe we can do a template. It's not, we're going to throw a lot of that away. Based on, well, not the input, right? So this is essentially the AI of the game, right? The enemy AI is determined based on where the ball is. Okay, now let's get rid of this warning. We may end up needing Delta, but for now. So this is wrong. I think one thing we can do is we can get, let's make a function. Get ball position. I don't want to do that. Can we do this? Wait. If I do this, so what I've been told is the difference between the colon equals and the equals is that without the colon, we are not saying that the variable I'm declaring here is always of the type of the thing from the right-hand side of the expression. If I have the colon, then you see it's a node. That's the type. Cool. So this is right and wrong. So this should be Y. The Copilot is using X because we haven't updated the script down here to say, oh, we're trying to move in the Y direction. So how do we feel about this? If the ball position is smaller than the position of the paddle, then it's above, and we move in the negative Y direction to intercept the direction of the ball. This behavior, I think this is fine. Sort of. It's gonna have some problems. I think one thing, I don't know. Let's see. Let's play and see what it does. So one, this is gonna be really boring because I think the ball is just going to bounce back and forth. We don't have any way of like imparting momentum, but you can see the AI kind of shaking us. This is just trying to perfectly line up the where its center is. Yeah, we're not imparting momentum with those bounces. Okay, so one thing I want to do is we disabled in the ball script being able to set the random direction. So I think that'll make it a little bit more interesting to see the behavior. If the ball is going, there we go. Okay, the AI succeeds at being an AI. It's a little jittery though, a little jittery. Like it needs to basically say, hey, this is good enough. I can stop trying to get it perfectly aligned. But it works. Oop, I messed that up. Okay. I already know the thing we should add down here though. I'll make it a little bit more interesting. Yeah, let's do acceleration somewhere in that list of things to do. Okay. So for our AI paddle, let's see. Let's do this. So first of all, just go ahead and say this. Cannot infer the type of ball position variable because we didn't say what the type is. This is returning a vector 2. There we go. Let's say var distance. Positioned at distance to ball position. Okay, cool. Copilot knows about methods. Returns the distance between this vector and param 2. Right? So we want to say, let's have a close enough. Okay, let's think about this. We could do this, but I think what we can do instead is we're gonna, this logic will be down here at the end. Right here. And then what we're gonna say is so else if so I mean, this is always true. Yeah. So I think what I'll do here is we're just going to get rid of the third branch. This is what I was thinking about. It's like, oh, well, we have this condition, or otherwise we do this, but we only do this if either of these are not true, and that's really unlikely and would be covered by this case. So what I'm really doing is I'm really changing this to here, and then, I mean, we can leave the if direction. It's not really necessary though, right? Because for this to stay 0, both of these would have to be false, and that would mean ball position was exactly equal to position.y. I see a issue though. So we're doing this distance, and we're looking at the actual on-screen, well, world coordinate, I guess, maybe, but no, I think they're the same. We're talking about pixel units, I think, in these values. But regardless, it's talking about like the actual distance between the two things. But all this stuff is about just the y distance. So I think what I'm going to do here, instead of using distance 2, what we're going to do is we're just going to say the distance is, we have like absolute, yeah, there you go, ball position y minus position not y. So what is the distance in the y-axis between where the ball is and where the paddle is? If it's close enough, just approach 0 velocity. Doing this instead of saying just set the velocity to 0 means that if we're kind of moving, we'll continue moving a little bit until we slow to 0. I think that is good. It probably doesn't make a significant difference either way. But there we go. So now it doesn't jitter as much. You can also see, because we put the collision shapes and was it a rigid body that we ended up using? The paddles can't go above or below the screen, right? We can't go above it because there's a solid wall just off screen. I mean, even if it was on screen, you wouldn't see it because we don't have a sprite or anything indicating it. Now you could do more fancy things with the AI, and you would probably need to, as you accelerated the ball, to say, oh, where's the ball going to go? And like have the AI side predict the bounce route and move towards where it anticipates the ball going. And I suppose in doing that, you could make I don't know if it would, as good as you could get. Anyway, perfect reaction kind of situation. Okay, well, that's fun. Sort of. I mean, it's cool to make a thing, but it is Pong, a 50-year-old game. So there's an AI paddle. Let's add goalposts. So how do we do that? So we don't. So what we did for walls is we have a static body 2D. Can we? What do we want to add so that when the ball enters the area, we detect it without it interacting in a physical sense, and then we can write some code that will remove the ball and add a score, I guess. So something inside of node 2D, some kind of collision object. Maybe something inside of physics body, something that, so we use static body, right? Not rigid body, it was static body. A 2D physics body that can't be moved by external forces. When moved manually, it doesn't affect other bodies in its path. Okay, so let me take a look at the walls. Are there properties on the walls? So physics material override, constant linear velocity, angular velocity, collision input. What is physics material? Okay, so we have a physics material. Interesting. Oh, look, there's a back. Nice. Let's go back to how it was. Let's collapse down some of these things. Yeah. Rigid body? Full 2D physics. It can't be controlled directly. I mean, it's the same thing as the other things said. So the body's behavior can be adjusted via lock, rotation, freeze mode. Oh. I don't think that's what I want. Like, I want something that detects collision. So maybe I do want Area 2D, but the issue before was that we were not seeing collisions. What is physics server 2D? I don't know. I don't think we're interacting with that. So Area 2D is a region of 2D space defined by one or more collision-shaped 2Ds. It detects when other collision object 2D. So all of this stuff here are collision object 2Ds. So you would think if we define an Area 2D, and then we have to define a collision shape. Hey, it's in our recent list. And then we need to select a shape. So we'll do a rectangular shape. We'll come over here and get close so I can see what I'm doing. I'm gonna move that. And we'll just make a rectangle over here. The height of the screen. Thereabouts. Yeah. So we're gonna say this is the player goalpost. So if I were to attach a script, we have a basic template here. How do we know about stuff entering this area? Hey, look, there are signals. I was wondering where signals were. Area to do, area entered, area exited, area shape entered, area shape, body entered, body exited. So, body entered? Is this... Do we think this is helpful? What is a group? Hey, look, there's a tab called Groups. And we can create a new group. It's very convenient that I just stumble across these things as I need them. What does global here mean? No hover over? Okay. I guess that's okay, cool. So if I run this and the ball enters that area, do we see a message? No. That's too bad. Okay, we'll figure out maybe if we have to do something to hook up the signal. All right. Let's see. Let's go back to here. Let's do something else. Let's add a print statement just in case I've done something wrong with on area 2D body entered. Maybe I need to do something here. So let's see. If I go back to our player goalpost, area 2D body entered, connect. Oh, maybe I should connect it. Maybe I should connect it to the ball, and then this logic could be in the ball. No, I don't know. Oh, cool. I can. Okay. Cool. Connect. And it exists. So it just. I could have just called this on body entered, I suppose. I could have called it anything. Let's save and see if it works. Let's get out of the way of the ball and see. Boom. So we see one message here, body entered the goalpost walls. So we have some intersection between our wall objects and the goalpost, but that's fine. We did detect when the ball entered the goalpost. So, and then, yeah, great. So that was easy-ish. And we are going to do these things eventually. Okay, cool. So then we just do the same thing for the other side, right? We're just gonna duplicate. I call this AI goalpost, and W to move mode. Drag this over to here. Try to get that aligned. There we go. Do we really want to have separate scripts? Can we do... Here's the thing. Ooh, let's do this simple. Is player. Okay, so if I do that, and then I look at the inspector. So for player goalpost, I set this to true. Cool. And then for AI goalpost, it's not true. Okay. And then, yeah, okay. Let's a little bit more room here. So we're gonna say, if is player. There we go, and we have two different things we can do. And we can, swap that out. But now we should be able to detect whether the player got a score or was scored against. There we go. Player goalpost, ball entered. Is there a way to just like restart the scene from in here? goalpost. We will make it so that there is a continuation of the game after the score. So I guess the problem is the AI is not going to lose. So how are we going to test this? Well, let's temporarily turn off the AI so we can make sure it works the other way. So instead, what we're just going to do is we're going to return. That'll prevent the AI paddle from moving. And then we just have to make sure that, oh no, that is an unfortunate start. We probably need to add some constraints around the direction of the ball on start, so it doesn't like perfectly go up and down and get stuck, right? All right, so AI goalpost, ball entered. There we go. So that works. All right, let's undo that. Let's look at ball. Let's say to do. Well, actually, what's this now? Generate a random angle between 0 and 2 pi. We probably don't want to actually do that, because that would be like, you know, a whole circle, as the second comment Copilot was going to give us said. What we really want to do is we want to generate an angle from let's see, 0 to 2 pi. So 0. So the cosine of 0 is 1. So we're just thinking about, I think a 0 angle is directly right. So we want, we actually want either between negative, what? Probably like pi over 2. And pi over 2 in between, or between, what is that? Negative, radians are hard to think about. If you're not used to doing that often, and it's been a while. So down is then, or wait. So pi is to the left then? Pi radians is to the left. So we want 1/2 pi, 1.5 pies. Well, that's 3 pi over 2. 3 pi over 2 and 5 pi over 2. 6 pi over 2 is, wait. Help me out here. What do we want here? This is maybe I should just draw a picture kind of situation. Although, okay. Have a circle. Beautiful. Have an arrow. Right. So if this is 0 radians, 0 pi radians, yeah, 0 pi. I'm just saying, I mean, it's just 0, right? But it's 0 times pi, so that everything will be in relation to pi. So this is also 2 pi, right? So there's 2 pi radians in a unit circle. So this direction is 1 pi, or just pi. This direction is 1/2 pi, right? And this is 1/4 pi. No, so I was not going to do all the cardinal directions. In case you were thinking that's where I was going. So this is 1/4 quarter of pi. Which is fun because it's not a quarter of the pi. Haha. And this is negative 1/4 pi. And the other direction we're interested in is 1 1/4 pi. And 3/4 pi. Right? So basically, when we choose the direction, the random direction of the ball, we want to be in this wedge or this wedge that goes from, and we want a continuous number, right, to choose within. So we can't just say, oh, go from, 1 3/4 pi to 1/4 pi. We want to say negative 1/4 pi. So how do I want to do this? I want to say the random angle is a float, and it'll initially be 0. And we're going to pick a, if, okay, we can get a random integer. If it's even, we choose one random angle, otherwise we choose the other. That way we're randomizing, either we're going left or right, and then within that we're choosing the exact angle. So this is going to be negative pi over 4, so 1/4 pi, to 1/4 pi, so this will be our right hand. And then otherwise, maybe Copilot will do the other half for me. Yeah, pi, nope. We want this to be 3/4 of pi. Yeah. 3 times pi over 4 to 5 times pi over 4, right? So pi plus 1/4 is 5/4 of pi. Okay, so that gets us a direction expressed in radians. Okay, and then we use some trigonometry to turn the direction into a vector. And so now when we start the game, the ball will always go roughly in the direction of the goal. And slip through. All right, cool. But if we do it again, it'll go either right or left, right? It happened to go left this time. But if we start the game again, maybe it'll go right this time. Yay! All right, so we won't ever get stuck in that. Oh, the ball is going perfectly directly up or down. Important things to think about. Okay, so that was a fun little side tangent. Okay, so we have goalposts. Now we need a scoreboard, right? So we want to keep track of how good we're doing against the perfect AI opponent. So how do we do that? Well, let's find out. I think what I'm gonna want is maybe just something here along the top. And what that something is, I don't know. Let's add a shell node. So there are things, I know that there's a label. Okay, so there is a label that is a control for displaying plain text. So the easiest thing to do is, well, we don't want it inside of the goalpost. Make a player score label. Maybe let's create a node. Node 2D. Nothing just a node 2D. Because it has position, rotation, scale, and skew. And we'll group our labels together. So No, no, no. You go inside. There we go. All right, and then we add another child node. And this is gonna also be a label. And we're gonna call this AI score label. And we'll call this node scoreboard. Okay. Is this, yeah, that's the scoreboard. So we're gonna put that kind of centered. And then to see how this all works. Okay, so the player score, 0. AI score, 0. Let's see, horizontal alignment center, vertical alignment center. Okay, and then the same thing for this one. I could, I guess, make one label, and then in the code we would like. We need to keep track of the score anyway. We'll probably add a script to scoreboard to keep track of the score. In fact, I already feel like I know where this is going to go. So, but first, let's see. Player score can be moved over here. Something like that. And then AI score can be moved. I don't know. Not 70, that's too far. What are we... What? 100 units away, so I guess that should be like right there. I'm just looking at the ruler at the top, kind of aligning with the center of the character. That's fine. Okay. Text could be bigger, definitely. Can I select both of these and manipulate them both at the same time? Let's see. Control, canvas, item. Lots of interesting text options that I'm going to ignore. So label settings. New label settings. Which we'll edit. Font. I found a font, actually. So one of the things, if there's interest, I can definitely share. I have a workflow where I've been accumulating notes for preparing for this stream. And one of the things that I came across a CC0, so no attribution required, effectively public domain, Creative Commons licensed asset. And so found this on OpenGameArt. It's a bitmap font. How do we download it? It's just a PNG file. So that is gonna be maybe annoying to deal with at the moment. Like if I say new font file, supports bitmap font. Okay. Edit. Okay, how do I do this? Let's go back. I feel like I skipped a step. If I load. Okay, I could load a PNG. Okay, let's just try this. We're not gonna learn things if we don't try. So please just ignore the details of files on my computer. Let me go find where we're storing this project. It's a new game project. There we go. Actually, let me just put it in downloads. I'll grab it from there. Boop, boop. Maybe I shouldn't have the primary monitor on Windows be the monitor that I stream from. Maybe. So can we create a folder? And we'll call this assets. And I could do more organization, but I'm not going to. I'm going to drag PNG file. Assets. Okay. So can I just say, hey, use this? No. Can I load? Press texture. Okay. Cool, cool, cool. All right. So not the right thing to do. Clear. Open documentation. Hey, look, we can just look at the documentation. This is kind of like API docs, isn't it? What about font? Font file? Font variation, system font? I'm just going to give myself another minute or two to see if I can figure out how to just use that PNG file. I suspect, though, that that is going to be not so easy. So if we can't, do some quick scanning, figure that out. Bitmap font importer. Nope. Nope. Yeah. So like, if we look at this file, can we just open? Yeah, we can. So it's just a, it's an image, right? It has characters in it. To make it a font, we have to like relate the contents of the file to like, oh, this character is 0, this is 1, those sorts of things, right? So I don't know that I want to do that right now. How do I leave? Let's just go back. Okay, so this is cool and all. Close docs. Okay. Close. Oh, right. Script tab. Hey, script tab. Right. Still getting used to the UI. Alright, anyway. So let's go back to messing around with labels. So we have label settings. And we can go edit it. And we're just going to select system font. And then edit that. So just, it's going to be open sans, semi-bold, whatever. Okay, if I go back, you can set the size. I'll set this nice to like, yeah, that's probably 42. 42 is good. And the color, well, we're not doing anything with color, but give it a little shade. I'm very not focused on art today. Let's put it that way. You can tell though I have been giving some thought into kind of style of like, hey, I want to make some, you know, some very basic starter games, but I want to have resources and stuff to be able to have things that don't look bad. Not like commercial quality, not even like indie dev commercial quality, but just, you know, kind of figuring out how to do things. Okay, so anyway, we have labels. How do we do things with labels? So what I'm thinking is that maybe we make some, I guess the easiest thing to do, right? The easiest thing to do, the most direct thing to do, let's use, the easy is so overloaded, right? Is in our goalpost script. Is there an easy way to rename a script? Like if I want to rename this. Rename. Move? No. Edit dependencies. View owners. Create new. Copy path. Rename. There it is. Okay, I just want to call this goalpost, right? Because it's both for the AI and the player. Now if I go back to here, My file has gone away. Just find the new one. There it is. So what I could do here is I could be like, hey, var player score label equals something like this. I guess it would be like // what's the path? Scoreboard, like that. And then we would do things, but then is goalpost gonna really keep track of the score of the players? It could. Right, so then we have like var player score, AI score, and then we say player score plus equals 1, and then we do other things, and then we do the same thing here where we update this. So if I just do this, does this work? I'm gonna let the AI win. There we go. But it's the wrong direction. If is player, then the AI just scored a point. So this needs to be reversed. But otherwise, yes, technically this works. It's a thing that I think is maybe not great to like mix some concerns together, but I need to take a break here because it's been another hour. So I'm gonna take a break for 3 minutes and we'll come back and